let's start by looking at your work. So last assignment was for the worm, skinning and blend shapes. And I already took a bit of a look at it, and it looks great. Okay, great. So Hunter, you submitted something. I haven't checked these out yet. So let's go from top to bottom this time. Okay, so let's start with Sophia. So the video of the worm. So one thing I like from the get-go is that there is a global controller. That's a great touch, great addition. And then the shapes of these two controllers are also really good. It's very easy to grab them. It's very easy to use them. For the scanning of the mouth, so one thing that I might suggest is to maybe have it affect less of this part, because it kind of goes over this section here. So like, especially when you move it up, you can see how this kind of part of skin goes up, and it shouldn't, right? So the idea is that mouse would probably affect just kind of this area maybe. But that's very minor. Overall, I think skinning looks good. You can also kind of try working on these sections so that the creases are not so harsh. But again, sometimes there's just no way of getting these parts perfect. Okay, great. And then the blend shapes, I like that you tried doing the phonemes, right? So that's really cool.
It was a little tough without a tongue, but I did the letters I could figure out.
Right, yeah. Yeah, makes sense. Yeah, and it's great that it's working when you're opening the mouth too. All right, let's look at the file now. On here, all right. Okay, great. So I didn't notice it in the video. It's great that they're all different. Colors. So white might not be a very good color for the controller, because sometimes during selection it might become white. I'm trying to think. Yes, so in this case, the controller becomes white by default. So that's why, to avoid that confusion, it's better to give it some different color. Okay, but for these controllers, it's great to have them all these different colors. Okay, so this is good. The worm can be rotated. Let's do something like this. And I like that all the channels are locked. Sorry, the attributes that are not being used are locked. That's great. There. Let's place him in this kind of pose. There we go. So for, oh, I see, right. So this is just translatable controller. Oh, and rotate. So if you're locking the rotation, it makes sense to hide it as well, right?
Part of the reason I locked that but didn't hide it is because I was kind of experimenting with whether or not it should be rotatable.
Yeah, I think
I wanted to ask you about that.
Yeah, I think it should be. Let's see. let's unlock. Where is it? The unlock selected. So because this way, we change to QWERTY keyboard. Because this way, so the way it's scanned right now, so I think it just needs a bit more smoothing here. But overall, it's nice to give this ability for Animator to like rotate it a bit. I feel like this controller would, so and this joint in general should control more of kind of this upper part, because to rotate the head, the Animator has this controller, but so they would use this controller to kind of to manipulate the top part. Right, so that's why I think if you kind of apply more the skinning more towards here, then I think rotation would look nicer, and also translation then would make more sense. It would then just translate the top part of it. Does that make sense? And yeah, but this this deformation looks good. So some intersection happening, that's fine. That happens. In order to avoid it, you can just do some more weight painting on this part. Give more weight to the head probably on these. But again, it's minor and it's kind of a pushed pose. Most probably, it won't be opening its mouth more than here. Yeah, so for this kind of controller, if this controller opens like this, for this one, it would make sense to kind of open just this part. Then it could kind of control the top lip, create this kind of Muppet, Muppet deformation. So yeah, so these are very minor notes. Overall, this works great. You have all the controllers right. Deformations look good. And let's take a look at the blend shapes. So those are the different phonemes: F, A, E, O, and so on. Nice. Yeah, so one thing you can do to make it kind of more usable for Animator, to make the blend shapes more accessible for Animator, is to place them somewhere where they can easily access them. So for example, on this controller, or maybe on this controller. I think this one is bigger, so it would, so they would look better here. But so what you can do is, and this is kind of for everyone to note, that here you can first add an attribute that kind of would separate all the blend shapes. Let's call it, so this will be unusable attribute. Let's call it mouth shapes. What should we make it? It doesn't really matter because we won't be using it, but let's make it something like this. Okay, so now we can lock it. And now the rest of the attributes can be the shapes. And I saw you added an image, so let's use your image as a guideline for us. This, by the way, I think is great. This shows very well the shapes you included. So let's say
those are actually kind of made with a combination of 4 different blend shapes.
Okay, gotcha.
But
right, in that case,
depending on the movement of the jaw. So.
I see, gotcha. Okay, well, I'll then use these ones. So it's F, A, E, O. So I'm going to create here F, a float. And then there was an E, right? Yeah, and let's make sure that the minimum and maximum is set to 0 and 1 because the blend shape can go between 0, goes between 0 and 1. Okay, so then we have an A, also from 0 and 1, and we have an O, also from 0 and 1. Okay. So now we want to connect these attributes to the blend shape. So the way we can do that is first we want to access the blend shape itself. So let's find that node here through connections. There it is, warm mouth blend shape. Let's just keep this. We can remove all the other nodes with this button so that we don't have to look at them. And in this node, you can see that in here you have all of your shapes listed. It's actually kind of difficult to tell here what they are. What if I highlight? No. Yeah, well, okay, so I know the order. So I assume here they're in the same order. So it's F, A, E, and O. Let me write that down. A, E, and O. All right, so now we can grab this controller. And the new attributes that we created can drive the shapes that we made. So they went as F first, then A, E, and O. Okay, so in this case, this will be our F shape. I didn't create minimum and maximums here, so you can see it goes all the way. This is the E shape, the A shape, and the O shape. Okay, so let's control right click. We can now edit this attribute to make sure it also has minimum and maximum. Okay. So yeah, so now this kind of makes it into a complete rig. So now Animator can use the shapes, so now they don't have to select a model in order to do that. So Animator usually just works with by selecting controllers and changing attributes on controllers. Okay, so this is just a demo kind of for all of you. It's not that you, obviously it's not that you did something wrong, it's just something you can include in your future rigs. Okay, any questions? No. All right. And yeah, this image is great. It's it makes a good demo for what your rig can do. All right, where was? I think I closed the Anim School website. Let's see. All right. Okay, Shantae. Let's check so there's a video. Let's see it. Nice. This controller works well. So is this one? Yeah, skinning looks good on these parts.
Thank you.
Hmm. Okay, good. Yeah, looks good. So I think the top of the head looks great. The bottom part, I feel like it has kind of the opposite problem from the previous rig we looked at. So it looks like it could use actually more deformation applied here to the bottom.
Okay.
Let's take a look now at the blend shapes. Okay, great. So you have your mouth up, down. Nice. Yeah, great. So for these kind of shapes, like the one side of the mouth, so usually you don't need to create them because you can just reuse this same shape, but just paint out part of it.
Okay.
And then you can do just the same shape on both sides. Okay, let's take a look now at the file. Yeah, but overall it looks good.
Thank you.
Okay. And also I like that you added different colors to your controllers. All right, let me try doing something similar to the previous one here. Something like that. There we go. Okay, so the fact that it's easy to deform it this way means that the weighting is applied well.
Thank you.
Okay, now let's see. So the teeth look like, so it looks like both. Oh no, just the bottom one. Yeah, so with the teeth, it's better to skin them in a way where their weight is kind of the same as this area of the mouth. So if it's not fully 100% to this bottom joint, applied to this bottom joint, you can apply it the same way. You can make the ratio the same way as kind of these birds are. Then you can avoid this intersection.
Okay.
But overall, this is great. Yeah, and this weighting also looks nice. I would just add a bit more weight to kind of this area.
Okay.
Okay, and for the top of the head, yeah, I think this is good. I would just just make it to have less weight on this part so that it just controls kind of the opening of the top of the head. And that's kind of, so the reason why I'm mentioning that is because that's kind of an important thing for animation, right? That animator
You're muted right now.
Yeah.
Yeah, there
Sorry.
you go.
Yeah, thanks for letting me know. I don't even know how that happened. But what I was saying is that for animation, it's important to make sure we have each joint or each controller affecting a specific part, right? So if an animator is moving this controller, so some of this weighting needs to affect the bottom part, but not a lot, right? They don't want like the bottom part of the mouse to move as well, if the purpose of this controller is to move this part. That makes sense?
Yeah.
Okay, overall, great job. Let's take a look at the blend shapes. Okay. Let's see. Yeah, they work well. And just the same note as previously. So usually you wouldn't have a shape that's responsible for for something like this or like this. They would usually be achieved as a combination of different sides, right? So this one would be like one side up a bit and the other side down a bit. Okay, but obviously for this assignment, I just want you guys to practice with kind of connecting these shapes and seeing how it goes. So, so for this case, it's great. Okay, any questions?
Nope.
All right, now let's move to Hunter. Okay.
Mine's a bit rushed since I kind of just got home recently, but I plan to fix it.
Okay, let's take a look. So all of these controllers are here and they're working. Okay, the top part is working. The bottom part rotates. Yeah, it looks like the blend shapes could use a bit of work, just making them a bit smoother. But overall, this looks good. Let's take a look at it in Maya. Wait, we already looked at that. Did I download this one? Maybe not. Okay. Let's see. Yeah, so one thing to just make it a bit cleaner, you can lock and hide these unused attributes. Also looks like there are values on these controllers. So controllers shouldn't have any values yet, and the keyframe here. So controllers shouldn't have any values, right? Because right now, if we try to zeroing this out, it will go to the origin. So when you're creating them, you can have them in a group, and then the group can have values. But for these controllers, you can just freeze the transformations, and it should work fine. Okay, and again, keyframes, you also want to remove. Okay, and it looks like there are some problems with skinning there, like at the top.
Oh, there's a lot of problems with skinning right now.
Gotcha. Okay, in that case, so you can take some time to, and then to finish to finish all the weight painting. Let's see. Yeah, and the same with blend shape. So this blend shape can be made a bit smoother, and the same with the other ones. Yeah, well, this one actually looks fine. Okay, but other than that, it's like the controllers are in the right place. So, and this one actually works pretty well. It just takes up too much waiting from here. So yes, it looks like you just didn't have enough time to finish it up. Okay, any questions?
Not at the moment, thank you.
Okay. Let's see now. Okay, Tatiana. Let's look at the images and the videos. So this is great. It's good to see a character in the pose, and I like that you added these flowers. Looks very nice. And let's see now the demo. Oh, sorry. Is there talking? Is there volume in this? No. Oh, I see. So this is the blend shapes. I didn't even notice. Okay, let me take a closer look. Okay, so this one goes down, and now the right one. Nice. It's good that you separated the two. Now both of them. Now the left cheek, the right cheek. Both of them together. Nice. And this is well. I like that you made it kind of a very pushed shape. It's better to make it too much than too little, because then it's always easier to tone it down. Okay, lips going front. Okay, that's the top. Looks good. The bottom also looks good. Okay, the rest of the controllers. So the weighting on these two looks good. This one also looks good. Yeah, I might suggest to smooth them out a bit more, so they're not as rigid, but again, for this assignment, the skinning looks fine, looks good. Okay, let's see. So these are more blend shapes. Okay, I see. So it's showing how they work together with the controllers. And yeah, and I think it's great. And from the images you showed, it's like I can see that the blend shapes and the controllers work well together. Like this shape, this face shape is very nice and appealing. Okay, let's take a look at the file.
Yeah, sorry, I always forget to save in binary because I'm modeling and then I saving in ASCII and then I always forget to change.
Gotcha.
Just push like save and.
I see. Yeah, that's all right. But it's quicker if they're binary files. They're just quicker for me to download and open up and such. Okay, let's see. These controllers look good. Then there's this one here and this Muppet one. Yeah, these look fine. I would maybe smooth out a bit this controller, but like in a very minor way. This one looks fine to me. Yeah, with this one, maybe the opposite. Maybe I would take out some weights here, but again, I would kind of experiment here. The fact that it's like so minor means that it's perfectly fine. Okay. Now let's check. Nice. Yeah. So you kind of combined the left and the right one. Yeah, that's great. So yes, this is kind of how you would usually have it with kind of different sides, right? For the smile and the frown. Yeah, and this is a very common shape too, like mouth out and mouth in. So that's great. If you have shapes like this, one thing you can do is, so you can place them all in the same controller, how I showed earlier, or you can have controllers for specific thing. So we can create, let's say, 2 mouse controllers. Here we go, and snap it here. Let's first freeze them, delete history. Now we can change the shape of this controller so that it's clear that it's for the corner of the mouth. What is maybe like Okay, so something like so. And this controller would be for the side of the mouse. Actually, I shouldn't have really frozen the rotation values because we kind of want to move it along the side of the mouse. So we would group it, make the groups pivot somewhere here. So now let's rotate it along the mouse, so something like so. Yeah. So now when we move the control, it kind of moves along the face. And with this controller now we can do something similar to before, but instead of creating our custom attributes, we can actually connect this translation to the blend shapes. So we can go to Node Editor. There's our NURB circle, and the NURB circle would be driving the blend shapes. Let's actually find, let's find our blend shape node itself. Where is it? Okay, I don't see it. I'll find it in General Editors Connections. I thought there would be less connections. Body, okay, mouse. Okay, so get IC. So these are all separate shapes. Okay, so I'll select this one and I'll connect the translate. Which one is translate X? Is it? Yeah, I can connect translate X of this controller to mouse out, because right now when controller moves this way, that's the positive direction. So we would want to have mouse kind of move out when the controller is going that way. So we can connect translate X to the mouse left. So now you can see it moves. So we can remap it a bit. I'll show you later how to do that. So right now it kind of moves a lot to just get the movement there. But that's that would be the idea. We can actually change. We can change the preferences to be, instead of linear, instead of centimeter, if we do millimeter. Let's try that. Okay, I think it's a bit better. No, probably about the same. Yeah. Let's keep it at default. Yeah, millimeter was a bit better, but still not ideal. There's a way to remap this value. I'll show you later a node that can help you with that. But this is kind of this is one thing you can do. And then you would connect the other direction of the controller to the out of it. So there is the mouth out, right? And there is a mouth in. So we can add mouth in here and connect it, but we want the reverse direction. So in order to reverse something, we can multiply it by -1. So if you remember, last time we looked at multiply divide node. So we can have -1 here in the input 2x, and then in the input 1x, we can connect translate x, and then the output will be connected to the weight of this mouse controller. So as a result, when we move it forward, the mouth will kind of go in, and when we move it back, it will stretch out. So that's another thing you can do, and you would have then the same controller on the right side and multiple controllers on the face, but as you move them, they would be actually triggering the blend shapes. So that's one way of setting up the facial rig. Okay. Any questions? No? All right. Okay, before we continue, one question for all of you. Would any of you object to me putting up your work online somewhere? Not just on Atom School's website, but for everyone to see? No? Okay, well, if you do feel uncomfortable with it, let me know. So this was a kind of suggestion / request from Atom School for us to kind of promote the classes more and put up students' work online. So I will now be occasionally doing it. I'm not sure where yet. It might be just on my LinkedIn page. Maybe I'll create kind of separate Instagram just for student work. But I'll let you know, and I'll send you a link. Okay. So that's everyone, right? We looked at all the work. Okay, now then let's start with the class. Okay. So today we'll be talking about different ways of connecting objects. So we'll be talking about nodes, we're talking about expressions, and set-driven keys. So right now, so nodes, you're already familiar with what nodes are. We'll be looking at utility nodes. So some things you're not yet familiar with, so set-driven keys and expressions. But by the end of this class, hopefully they will be clear, and you'll be able to use them in your rigs. Okay, so if we have two cubes, like so, and let's say we want a setup where when we translate this cube up, this cube translates with it. How can we achieve that?
With this multiple node?
Right, so for this case, we don't even need any nodes, right? So if we just want to translate it up, and this node to translate by the same amount, how can we achieve that?
Parent them?
Yeah, so parenting would be one way, but let's say we want them to translate the same amount, but not translate by any other axis. Let's say on X, if we move this one on X, we don't want this one to move. But when we move this one up on a Y, we do want it to move.
Use some constraint.
So you could use a constraint. You could use, say, a point constraint and only use the Y. But there's an easier way. And that's through just direct connection. So kind of your idea of the multiply divide node was close, but you don't even need it. You can just directly connect the two attributes. So we can go to node editor. Here we already have pcube2. We can remove this shape here by selecting it and pressing on this button. It won't remove the shape itself, it will just remove it from the node editor. So we have pcube2 here. Then we can add pcube1 and connect their translation. Here we can open up all the attributes, select translate Y, and connect it to this one's translate Y. So now if we move this one by Z, this cube doesn't move. But if we move it by Y, it does follow. Okay, that makes sense? Yeah. Okay, great. So we can also create some nodes in between here and change that value. So just now we looked at, and before we looked at multiply divide node. So multiply divide node is one of the utility nodes. So Maya has many utility nodes that kind of help us with math, with calculating things. And originally they were created to be used with textures. That's why a lot of times you will see they have kind of RGB attributes, and also they will have names that are related to color manipulation oftentimes. But later on they started being used for rigging, and right now they're mostly used for rigging purposes. Okay, so if we go, so because they were created for the purposes of texturing and material manipulation first, we can actually access them through Hypershade. So in Hypershade, you can see here there are all the different materials we can create, all the different nodes, but also you can see there are utility nodes. How do we access them? No, maybe they removed them from here now.
There's a tab down there.
So they're not shown here, right?
Under Maya, there's under lights, it says utilities. Is that where you're looking?
Oh, yes, thank you. Yeah, I completely missed it. Thanks so much. So yeah, so these are all of them. So we can access them here. So if we look through these, where's multiply divide node? It's somewhere there. So multiply divide. There we go. Multiply divide. So we can also, we can create it like so in here. We can also create it here in the node editors. So later on, they created node editor for Maya, so it's much easier to create it here. So one way you can access them is, so there's this button on the left top corner with the plus sign. So this kind of gives you a similar menu as the one you saw in the Hypershade. And again, you can see utilities here, and you can choose them from over here. So again, we can type in multiply divide, click it, and it will create it in our node editor. Another way to create them is by clicking tab, by pressing tab and typing in the node. So if I start typing multiply divide, it will suggest it for me here. Okay, so multiply divide node is probably the easiest and most straightforward to understand. It has these two inputs, input 1 and input 2, and we basically multiply one input by the other. And then the output contains the result of that multiplication. So it's actually interesting, when I started kind of learning rigging, I just learned by kind of doing things step by step. And to me, all the nodes always seemed like this black box that you just connect things to and then connect the output to something. So then at some point I realized it's just math. The only thing it does is calculation. So there's no no secret behind it. The only thing it does is that every frame, it will multiply these two values together, and that's it. So it's actually it doesn't do anything complex, really. So a lot of other things that are happening in the scene are way more sophisticated, right? This is just multiplying two numbers together. So let's create two cubes to see how we can multiply the values between two of them. So in this case, we have this cube 3 and cube 2. So what we can do now is put these translate y into input x, and this one translate y into input 2x, and then connect the output to translate y of p cube 1. Translate y, and this one is translate y. Okay, so now my question is, if I am to move this cube, let's actually position them more evenly here. So if I'm to move this cube up by 5, how much will this one move? If this is the kind of connections we have.
10.
Sorry? Why 10?
If we multiply it like 2 times, then 2 times 5 is 10.
Yeah, so why do you think it's 2? It's 2 times. Why are we multiplying it 2 times?
It says 2x, no?
So this 1 and 2 just means which input is it?
It's just the number of the input.
Exactly, yeah. So this is input 1, this is input 2. So it doesn't actually mean that we're multiplying by 2 in this case. So what this means is that we're multiplying this amount, the amount of p cube 2's translate y, by the amount of p cube 3's translate y.
Will it follow in between, like if you had, what's the word for it? When you constrain it to two things and it kind of gets stretched in between depending on where you put them, will it kind of follow in between like that?
So that's a good guess, right? Because we're multiplying those two values, but no. So think about it. The only thing we're doing is we are multiplying the attribute values themselves. So we're not really dealing with the movement, but the values, right? So if we move this one up by 10, and this one remains at 0, what will this one move up by? or by 5, sorry. This one up by 5. This one stays at 0. Then what will this one translate y be?
If you multiply,
Zero?
then maybe 0.
Yeah, exactly. So if we just move this one up right now, this one will stay at the same place. So now what if we move this one up by 1?
5 multiply 1 is 5.
Yeah, exactly. So this one will be then at the same position as this third cube. So if we move it up by 1, this one will move up by 1 as well. What if we move this one, the p cube 2, up by 2?
Then definitely 10.
Yeah, exactly. So now it moves by 10. So you can see it kind of changes exponentially as we move this one, and the same thing when we move this one. So in a way, here, now it does kind of keep being in between. So if this value is anything but 0, it will keep its position in between the two. But if this one becomes 0, then this one drops, because anything multiplied by 0 will be 0. Okay.
What happens when you go down into the negative side of the plane?
See, well, right now it will be still 0, right? But here it will be positive, right? It will just go up.
Because minus multiple
by
minus.
Sorry?
Yeah, because from mathematics, minus on minus multiplies positive.
Yeah, exactly. But then it will be different if one of them is minus and one of them is plus. Then it will start going in the negative direction. So exactly, so it's just, think of it as if you're multiplying two numbers. So each frame, and by frame I mean whenever we do anything with the object, each of this manipulation of the object, it refreshes and performs that calculation. Okay, so now with multiply divide, you can see we can change the operation from multiply to divide and to power. So with divide, it will divide these two values instead of multiplying them. So if, say, p cube 2 is going to be at 10 and p cube 3 at 5, where will p cube 1 be?
At 2?
Yeah, exactly. So if this one is at 10 and this one is at 5, this one will be at 2. And again, we can change, as we change the position, this value will change. Right? So this already, you can see, you can create pretty interesting movements with it and interesting connections. And then the power just puts something in the power of. So if, say, this one is 2 and this one is 3, this one will become 8, 2 in the power of 3. All right, so that's multiply divide node. Do you remember previously what other utility node did we look at?
Reverse.
Yes, exactly. Very good. Mm-hmm. Yeah, so do you remember what reverse did?
Just what are you trying to say? Inverted the input.
Yeah, exactly. So it's kind of reversed it. What it actually does, it just says that the output is equal to 1 minus the input. So again, it's just simple math that it does. And so when we have two values between 0 and 1, it kind of reverses it. But in reality, the only thing it does is just 1 minus the input. Let me write it down. So output equals 1 minus the input. So if we have, say, this cube at 0 and this one at 0.7, and now so in this case we just have one input, right? Actually, yeah, so we only really need one cube. So let's have this one at 0, p cube 2. Let's connect the input. So then it will be 1 minus, in this case, 0. And it's connected to p cube 1. So right now, the output will be just 1. So it's 1 minus 0. But as we come to 1, it will get slowly reversed. So in this case, it's kind of difficult to see because it's just between 1 and 0. Actually, I don't see it at all. So it should be 1 here. Let's say 0.5. Oh, I connected the wrong one. There, output X, translate Y. There we go. There. So at 0, it will be 1. At 1, this one will be 0. And say at 0.5, it will be 0.5 again. So that's why when we move between 0 and 1, it reverses the value. And it will reverse the value even with other movement. So that's why it's called the reverse node. But in reality, this kind of reversion, it's again nothing complex. It's just 1 minus or whatever value we're giving it. Okay. How do I now remove this? There, clear. Okay, so multiply, divide, reverse. Another useful node is plus minus average. And we can again just type it in. All right, so with plus minus average, you can see it's a little bit different. So it has input 1D, input 2D, and input 3D. So the difference between them is how many values can you connect at once. So say you want to connect all the translation values, you would use input 3D. If you want to connect just one value, you would use this input 1D, and you would connect your values to the slots available. So let's say we can connect our translate Y here and translate Y of the other cube here. No, to here, to the input 1D1. And this one is going to be input 1D0. So what this node does by default is it adds two numbers together, or any amount of numbers. So you can see here, as we started adding our connection and started connecting a value, it added another attribute. So unlike other nodes, it creates as many attributes for us as we need. So we can connect a lot of values together if needed. And then for the output, we can use this output 1D. and connect it to translate y here. So what happens if I put, say, this cube at 2 and this one at 5? Where will this cube be translated to?
7?
Yeah, correct. So it just adds those two numbers together. So if this one is at 2, this one is at 5, this one will be at 7. And it will keep moving up as we move these cubes up. So it just adds that value. And obviously, if we move these cubes down, this cube will be moved down as well. We can change, and instead of sum, we can do subtract. So then whatever this value is, it will subtract this value from it, right? So if, say, this one is at 10, and this one is at 5, this one will also be at 5. But if this one is at 8, so what if I change this one at 8 now? Where will this cube be?
3.
Yeah, exactly. So I change this one at 8, this one is still at 5, so this one will go down to 3. And then average just averages out all the values that we input. So in this case, it just does the average between two cubes. So it's a nice way to have something follow in between the two objects. Okay, any questions so far about the nodes? No? Okay. So these are the three probably most common used ones. There are some other useful ones. So one of them is a clamp node. So clamp node just clamps a value in between a certain minimum and maximum. Yeah, and so with all those other nodes, let's look at them once again. So say with multiply divide node, we can manually insert a certain value, right? So here we can connect, say, translate y to it to input 1x, but then we can multiply it by a certain value. So for example, if we multiply it by 0.5, it will just give half of that value. So if I move, let's connect the output here. So if I move this cube up, this one will move up by half of that amount because I multiplied this by 0.5. What if I change this value to 2? How will this connection change? If I put 2 into the input 2. Basically, how will this cube behave? So if, say, this one is at 5, at 4, 5. So where is this one right now? It's at 2.5, right? Because we're multiplying by 0.5. So what if I change this value to 2? Where will this cube be?
Then?
Yeah, exactly. So it multiplies it by 2, right? So 5 multiplied by 2 is 10. So this one will go up. So this one will keep going up as the left cube goes up as well. So it will always be two times more the value. Okay, so with that said, with clamp, we can also input those values. So we can input the minimum and the maximum values. And what it will do is it will change the input to only be between those values. So so it's in a way we're clamping something in between the two values. So if, say, at the moment, we can move this cube however much we want up and however much we want down. But let's say now we clamp it in between 5 and 10. So what that will do is it will only allow it to move in between these two values. It won't be able to move to 0, and it won't be able to move to 15. It will be clamped. Its translation will be clamped between this ceiling and the floor that we provide. Okay, so in order to do that, we want to input the minimum value, let's say 5, and the maximum value of, let's say, 10. As you can see, again, as I mentioned, so you can see RGB. So it was created first for color. So we can input 3 values, but if we're using 1 value, we just need to make sure that we place it in the correct attributes. So if this one is R, minimum R, we want to then place the next value, the maximum value, into also maximum R. And then the input we can connect from this cube. So let's say we want to connect translate Y. And then let's say the output will connect to the second cube. So output R will be connected to this one's translation. So now you can see we can move it to 10. So it follows when we move between 5 and 10. But then as we go further, as we go up or down, it then stops following. So it hits that ceiling and then it hits that floor. And those are the values that we provided here, right? If we change these values to, say, 2 and 10, then this cube will be able to travel more. So now it starts following, now it stops following. Okay, so that's the clamp node. The other useful node, which is somewhat similar, is remap value node. And with this node, so it does something similar, but it uses kind of 2 ranges. So you can see there's input minimum, input maximum, and then output minimum and output maximum. So what it does, it maps those 2 ranges to each other. So if, say, we have a certain input minimum, this is input minimum, and then this is input maximum, I max, I min, and then we have a certain output minimum and a certain output maximum. So what happens is wherever the values are on the scale, it will map them accordingly. So if, let's say, this scale goes from 0 to 10, and this one goes from 0 to 100, let's say our value is 5 here. What in that case will this value be over here?
50.
Yeah, exactly. So it will be 50. And then let's say our value is 7. So what will the value be here as the output? What will
75.
No, it will be 70, right?
Yes.
70.
Yes.
Yeah, if it's 7.5, it will be 75. So these are the values so this is how we're dealing with those values. So we can do exactly same thing here, maybe with lesser values. So let's say our input minimum will be 0, our input maximum will be 5, and our input minimum is 0, our input maximum is, let's say, 10. So if we have a case like that, and the input value is 2.5, what will the output value be in a case like this? So
5.
yeah, exactly, correct. So it will go right in the middle between 0 and 10. So let's test this out. Let's get our pcube2. Let's connect its translate y into there. I think it was, yeah, I think we connected to color. Let's see. Is it here? No, I'm not sure anymore. Oh, there it is, input value. Okay, so we grab the input value and we connect output value to translate y. So what's happening here now is if it's at 0, the other one is also at 0. If the first one, though, is at 2.5, the other one will be at 5, and so on. So if we are to move this one to 5, this one will be at 10. But you can see if we move anything, if we move it after 5, it doesn't move anymore. So in that way, it kind of works similar to the clamp node. And the same thing, if it's lower than 0, then this cube won't move down anymore. So it just maps it in between these two values. Okay. And yeah, and the way it works is just a linear, progression. So you can use a formula for it, which is just y is kx plus b. So once you have two, once you have two sets of values, you can change the letters to them, and then you can find what your y and then x is. So you you will have then two equations, and you can place those values there. So you could calculate it manually, and that's what that's the kind of calculation that this node does. Okay, any questions so far? No? Okay. So the next node is the blend colors node. And this one, again, you can see in the name, it's called blend colors. So it was originally created to, in order to blend two colors together. And, but again, we can use it to blend values as well. And the way it works is, actually, I'm starting to forget the actual formula. So if you, because that's a bit of a side note, if you want to, if you say you forget something about a node, or you want to just find out about the new node that you don't know about, you can go into Maya's node reference. So here under help, you can go to scripting reference, and here you can find node and attribute reference. And over here, you can find information about any node. So let's say you want reverse node, so you can click on that. So here you can read, so the output is simply 1 minus the input. And here is information about all the different inputs and outputs that it has. So the node that we're looking at now is blend colors. Okay. A utility node allows you to blend together two input colors or textures using a third value to control the blend. And here's the formula of how we use it. So it's actually somewhat similar to remap value node, and you can also use it during your IK-FK blend as well, because it has this blend attribute, which can let you blend between the two values. So let's say this cube is at value 1. No, let's make something bigger than that. Let's say this one is at value 10, and this one is at value 0. And we want to blend in between those two values. So what we can do is we can connect it to, let's say, color 1R. And this one can be at color 2R. And now we can output it to translation Y of this one. Oops. So now, by default, the blender is at 0.5, which means that this object will be exactly in between the two. It will be exactly in between 0 and 10, which is 5. But then as we change this blender attribute, it will go either to this cube or to this cube. So you can see, so when we were rigging our IK-FK arm, we use constraints, but you can actually use this node as well. And so you can use this blender attribute to blend in between whether you're at an IK mode or an FK mode. But again, from the point of view of the math that's happening, it's also pretty straightforward. So we have the one set of values. Let's say yes, let's say 0 and 10, and the other set of values, let's say 0 and 1, and we're just blending in between them. Actually, we don't need another set of values here. So we're in between 0 and 10, and now we're choosing. Now we have our blend attribute. So there. So our blend attribute will be between 0 and 1. So if the blender is at 0.5, then this value will be at 5. So if it's at 0.75, it will be at 7.5 here, and so on. So that's kind of how this node works. So it's very similar to remap values. You're just always remapping between 0 and 1 and whatever values you provide to it. Okay. So then the next node is conditions node. Okay, so condition node allows us to have kind of a logic behind our connection. So we can specify that something needs to happen if the logic we provide ends up being true or false. And that logic can be whether two numbers are equal, that's the default, whether they're not equal, if one is greater than the other, is one is less than the other, or if they're greater and equal or less than or equal. So the way that works is, let's say we want something to happen when p cubed 2 reaches 10. So if we translate, for example, until 10, nothing happens. And then once we reach after 10, we want p cubed 1 to follow it. So what we can do then is we can use, so first we want to connect the value to the first term. So this is the value we'll be comparing, and we'll be comparing it to 10. So let's say if value becomes greater than 10, then, wait, what did we decide? We want it to start following once it becomes greater than 10. And it won't just start following, it will kind of snap to that position. So then out color R will be connected to translate Y. And color if true can also be translate Y here. So basically, if this equation is true, no, to color R, there we go. If this equation is true, if first term is greater than this, then p cubed 1's translation Y should be the same as this p cubed 2's translation Y. So here. And you can see, so right now it's not following, and here it kind of snaps and starts following. So that's the idea here. And we don't have to, it doesn't have to be with translate Y. So we can, for example, say that whenever it's greater than 10, the translate X should become, should become the same. Let's say, oh, they're already offset. So let's say here, these cubes are positioned apart. But once we raise it above 10, this one kind of goes to this one's position X. And then we can say that if it's false, for example, something else can happen, some other connection can take place. So this node is pretty powerful in creating that kind of more complex logic. Okay, any questions so far? No? All right. So now that we talked about nodes, let's look at other ways of connecting objects. And one other way is through set-driven keys. So set-driven keys can be, so they're very similar to remap value node, but we set those values as we set the driven keys. So set-driven keys are a bit slower, not a bit, they're kind of slower than nodes. They're also often not as easy to troubleshoot, but they're usually easier to use for kind of less technical people. So for example, animators would prefer to add set-driven keys because it's just more intuitive to set them up. Okay, so to create set-driven keys, let's continue with our translate Y. So you can press Control, right-click, and select set-driven key here. So in this menu, you'll see an option to, so you'll see two windows, one for driver and the other one for the driven. So the driven will automatically populate from the object that we have selected, and the attribute that we have selected will also be automatically selected. So here we can select different attributes, and we can also load the driver into this first window. So to do that, we want to select an object that we want to drive, this second object, and click Load Driver. If you want to change this object, by the way, we can select a different one and click Load Driven, this button here. So in this case, we want Translate Y to drive this one's Translate Y. And let's say we want them to be the same as 0. So we can set a key here. So when they're at 0, be the same. But now when this one, for example, it's at 5, we want this one to be at 10. So now that we position them this way, we can again set the key. And what this will achieve is that now, if we are to translate this first cube, this one will interpolate depending on the keys we set. So as it reaches 5, this one will reach 10. So it won't go after 5 and it won't go below 0, but it will go in between these two values. So you can see it's exactly like what we did with remap value node. The one difference is that you will see in the node editor, instead of creating a node, it created this animation curve node. And what that means is that we can edit it in the graph editor. So if we go to animation editors, graph editor, we can change the way this curve is. So we can, for example, make it start, start slow and then get fast, like so, right? So we can change the way this curve is shaped. So now if we are to start moving this cube, this one moves very slowly, but then starts moving faster. So it's kind of, you can change this curve, and that kind of allows you the manipulation of, or the connections of this object to happen in a more intuitive way. So that's why you can use, this way. But again, it's better to avoid it when possible. All right, so that's the centering keys. And then you can also create expressions on your attributes. Again, expressions are a bit slower than nodes, but oftentimes you kind of have to use them, especially when your logic is very large. It's kind of impossible to create so many nodes and to keep track of all of them. So in that case, you can use an expression. So to create it, you can hold Control, right click, and select expressions here. And now you can create a connection for pcube translate Y by just writing it down. So let's say we want pcube1 translate Y to be the same as pcube2's translate Y. So do that, we can say pcube1 translate Y is equal to pcube2 translate Y. And so the syntax here is based on MEL language, which is a Maya embedded language. But some things are a bit different in expressions rather than in just pure MEL. But the syntax is the same. So you would use first the name of the object, then dot, the name of the attributes. And in this case, I used an equal sign to show that one is equal to another. Now we can click Create, and that will create an expression for them. And you see now this attribute changed to purple. And pcube1 is now following pcube2. So the same as we did with nodes, we can add some math to our expression, and this is kind of just so the logic here is the same as just with any math equation that you write. So for example, if we want it to be 2 times more, we can say multiply by 2. Now we can edit our expression, and this cube will be moving 2 times more than this one. We can also go in here again and selecting translate to y, so that's where the expression is assigned to. And I can change it to 0.5, multiply by 0.5. Click edit, and now it will move 2 times less than the first cube. And we can also add more logic to it. So we can say, for example, multiply by 0.5 plus 2. So instead of creating 2 nodes, we can just write one expression. So it will be half the way plus 2. It will move like so. And there's way more things you can do with expressions. You can create if-else statements. You can use frame as an attribute to say that something is changing as you are kind of scrolling down the timeline. You can, for example, make the texture change as you're scrolling down. It's very powerful, but usually it's better to use nodes just because they're lighter on Maya. Okay, any questions? No? Well, I think that's it for the class today. For your assignment, you will want to go to the materials. Where are they? Here. And download the pendulum. Wait, that's a different class. There. And download this Galileo pendulum clock. So you can find videos online of how it's supposed to be working to kind of for your reference. So this is how it's structured, and you can read a lot of information on it. Here, this is a 3D printed model that shows how it works. So the person moves this main part, and you can see all the parts of it then move. So this wheel starts turning with it. This part keeps moving too. So this first part moves this one up and down, that moves the wheel, and that moves all the other of the wheels. So you can see how this works here. And depending on how many parts of the wheel there are, it will move with a different speed, right? It will make it will make different amount of rotations depending on its size. Okay, and where was it? There it is. And so you have a model of it in Maya, and I'm kind of giving it up to you how you want to rig it. So now you know all there is to know about nodes, that expressions, set-driven keys. So you can choose any way that fits you most to rig it all together. So we have this part. So if we move it, it should move the rest of the mechanism. So it should move this part, that one should move this one, so this one, and as a result, all the cogs of this machine should be moving with it. Okay, any questions? No? All right, I think this is a very cool assignment because it kind of, first of all, it gives you a chance to practice with all the different nodes. Also, it kind of gives you a chance to do something that's like very real and mechanical. And this is something very similar to what you might encounter if you're doing hard surface modeling. If, say, you're like doing some kind of robot and you want to kind of rig it up a bit so that all the parts move nicer. You can use this logic for something like that. All right. Any final questions before next class? No? All right. In that case, I'll see you all next week.